Welcome to PNX Labs. You are inside one of our aerospace facilities, where we perform the testing of different engines used for plane propulsion. In this laboratory you will apply some basic fluid dynamics concepts to analyze how aircraft engines work. Make sure you have read the pre-lab document assigned by your professor, so you can understand the tasks you have been assigned to. So, if you are ready, let's get started. Walk down below to the blue marked area to start with the jet engine simulation. You are now in the turbojet testing station. The turbojet is an air-breathing jet engine, typically used in aircraft. It consists of a gas turbine with a propelling nozzle. The gas turbine has an air inlet, a compressor, a combustion chamber, and a turbine that drives the compressor. The compressed air from the compressor is heated by the fuel in the combustion chamber and then allowed to expand through the turbine. The turbine exhaust is then expanded in the propelling nozzle, where it is accelerated to high speed to provide thrust. Before working on the tasks assigned by your professor, take a moment to inspect the engine. You can use the red display switches in the control station to turn on and off the visibility of the engine sections for a better visualization. When you finish, follow your task sheet and complete the tasks assigned by your professor. After you complete your tasks, move to the other marked locations to experiment with the turboprop and the turbofan engines. Alert! Turbofan controllers are activated. APU initialize in 5, 4, 3, 2, 1. Fuel igniter initialized. Fuel injection started. Afterburner activated. Afterburner activated. Alert! Turbofan controllers are activated. Alert! Turbofan controllers are activated. Alert! Afterburner activated. Controllers are activated. Alert! Turbofan controllers are activated. Alert! Turbofan controllers are activated. turbofan controllers are activated. Alert! Turbofan controllers are activated. Engine stop. You are now in the turbofan control station. The turbofan, or fan jet, is a type of air-breathing jet engine that is widely used in aircraft propulsion. Turbofan thus can be thought of as a turbojet being used to drive a ducted fan, with both of those contributing to the thrust. The ratio of the mass flow of air bypassing the engine core, compared to the mass flow of air passing through the core, is referred to as the bypass ratio. Alert! Turbofan controllers are activated. Through a combination of these two portions working together, in 5 engines that use more jet thrust, 2 relative to fan thrust are known as low bypass turbofans. Conversely, those that have considerably more fan thrust than jet thrust are known as high bypass. Most commercial aviation jet engines in use today are of the high bypass type. In this simulation you will work with the Trent 1000, a high bypass turbofan engine used in many commercial aircraft. Follow your task sheet and the instructions manual to operate the engine. Remember that you can use the visualization switches to gain better visibility of the engine. Good luck and enjoy the simulation. Warning: the turbofan is reaching high speeds. Do not step directly in the back or in front of the engine. Fuel injection stopped. You are now in the turboprop control station. A turboprop engine is a turbine engine that drives an aircraft propeller. In its simplest form, a turboprop consists of an intake, compressor, combustor, turbine, and a propelling nozzle. Air is drawn into the intake and compressed by the compressor. Fuel is then added to the compressed air in the combustor, where the fuel-air mixture then combusts. Engine starter. The hot combustion gases expand through the turbine. 3, 2. Some of the power generated by the turbine is used to drive the compressor. The rest is transmitted through the reduction gearing to the propeller. Further expansion of the gases occurs in the propelling nozzle, where the gases exhaust to atmospheric pressure. The propelling nozzle provides a relatively small proportion of the thrust generated by a turboprop. Follow your task sheet.